Today, lesson 19b, the second day of exponents. Yesterday, we kind of started that process with the basic stuff. Much of that you learned in the 6th grade, but we extended it out to some ideas with variables as well. And today, we just sort of continue moving forward with the idea of exponents. And tomorrow, we finish off the basic idea of exponents. All right, so let's just go ahead and get started. Simplify the following using mathematical properties. So this is just an extension of what we talked about yesterday, but today I'm going to infuse in there the actual mathematical properties would allow you to do some of these specific things. So when we have 5x to the third times 3x to the sixth, when I split it up into pure multiplication like this, that's another idea of extended product, which I threw out that term yesterday, the idea of extended product. Now, if I sort of rearrange things, if I put the two coefficients together, and if I put the variable parts, the x parts together, that's an idea of two things at once, the commutative and associative properties. And it is that idea, and most of you do all of that in your head, but I'm just bringing in the idea of what allows us to do this. And of course, that now simplifies to 5 times 3 is 15, and x to the third times x to the sixth is x to the ninth. So that simplifies to 15x to the ninth. Now, listen, I want to make this very clear. I'm not asking you to go through all of those steps. You should be able to jump right from the original problem to the answer. I'm just showing you why we are allowed to do those things. That's all I'm doing. I want to make that very clear, okay? So, can you quickly go ahead and do part B and part C? So part B, once again, I'm going to show you by using mathematical properties. First of all, I'm going to extend the product. Then I'm going to regroup, putting the coefficients together and the w's together. And so that leads us to negative 44w to the 8th power. Part C, same idea. Group the coefficients together after I extend the product, put the c's together, and that simplifies to negative 24 c to the 11th power. Okay? All right, so today the one new thing that we're adding is power to a power. And I mentioned yesterday that you're not going to hear me mention anything about shortcuts. Those are things that you need to sort of figure out on your own. If you figure them out on your own, feel free to utilize them, but you will not hear me mention anything about it. I'm going to break it down to the essentials of what is really happening. So if we have n to the third power, all to the second power, I'm going to show you two different ways. One way, breaking down what's within the parentheses, sort of thinking about order of operations. And n to the third means n times n times n. I'm extending the product. Now, n times n times n, all of that to the second power means I have two groups of n times n times n. And then from yesterday, that leads us to the fact that we end up with n to the 6th power. So if I extend the product out twice, that leads me to n to the 6th power. And once again, I know some of you want to say, but can't you just? And the answer to that is probably yes. Okay? Now I'm going to take a look at it a different way. What if I think of it as dealing with that outside exponent first? In other words, I have two groups of that n to the third. That's what n to the third to the second means. I have two of those groups. And then, if I split those up like we did yesterday, we end up, obviously, with exactly the same idea there. Both of those lead us to the fact that n cubed, all of that to the second, is n to the 6th power. Okay? All right, the notes are a little bit out of order. So what I want you to do is to make sure you're doing the right thing here. You're going to do number 2. Well, who can tell me what part A is? Yes. It's 3 to the 20th power. And here's the reason why. If I extend the product, 5 3's that we're multiplying together, and then I write that out 4 times, I have 20 3's altogether. So that is 3 to the 20th power. All right, quickly do part B, part C, and part D. Okay, so I think it's pretty obvious what all three of these have to be, but the issue is, and the same thing happened yesterday when I walked around, part B. In part B, does the -2 need to have parentheses around it? Yes or no? Yes. Yeah, that's around the base right there, because if you don't, this, if I asked you to figure it out, would give you a positive answer. We talked about that yesterday. But if you wrote your answer like this, that actually has a negative answer. So those are two totally different things. If the base has parentheses around it, the standard rule is let's make sure that in our answer, the base has parentheses around it. Okay? All right, part C is obviously 5 to the 24th power, and part D is x to the 40th power. All right. We're going to now do the other part that we skipped on the notes on the front side because the notes were a little bit out of order. So now I'm going to extend out that idea of a power to a power. Here we have -4x squared y to the 4th all to the 3rd power. So if I extend the product, it means this, and this is where you should be writing stuff down. It means I have three groups of that -4x squared y to the 4th. Once again, that is extending the product. Now I'm going to utilize that very first thing that we talked about today, and that's by using the commutative and associative properties together, put all my coefficients together, put all my x's together, put all my y's together. Something like this. Once again, that's just using the commutative and associative properties all at once. Regrouping. Putting the coefficients together, putting the x's together, putting the y's together. And while I have been encouraging you so far to do things in your head, this will be the most missed type of problem for people who are doing things in their head all the time. Okay? They'll forget that you really have three of the -4s as well. So this simplifies to -64, -4 times -4 times -4, x squared times x squared times x squared is x to the 6th, and of course y to the 4th times y to the 4th times y to the 4th is y to the 12th. Okay? Any questions about this one? All right, let's go to the back side of the notes, and everybody do number 3, part A. Most common mistake is to write 5, a to the 12th, b to the 20th. One person in here wrote that. I mean, if you wrote that, you forgot to do 5 to the 4th power as well. It's each of those parts to the 4th power. It's essentially 5 to the 4th, a to the 3rd to the 4th, and b to the 5th to the 4th, right? Because you have 4 of those groups of that 5a cubed b to the 5th. And if we then utilize the properties and sort of piece everything together, that's what we have. 5 to the 4th power, or 5 times 5 times 5. 5 times 5 times 5 times 5 is 625. And then a cubed to the 4th is a to the 12th, and b to the 5th to the 4th is b to the 20th. So that simplifies to 625, a to the 12th, b to the 20th. Okay? All right, go ahead and do part B and part C, and then we'll compare with our shoulder partner, and then we'll deal with the last idea for today. Part B, -3wn to the 8th, all of that to the 7th. If I write it out by extending the product, it looks like this. And then grouping all my items together. One of the things we talked about yesterday was when we have multiple variables, we need to write the variables in alphabetical order. So that's actually why I went ahead and put the n's first before the w's at this point. And then we need to figure out that -3 to the 7th, which is -2,187. N to the 8th to the 7th is n to the 56th, and w to the 7th is, or w to the 8th. Wait, that should be w to the, this should be 7th, shouldn't it? This should actually be 7. There's only 7 of them, not 8 of them. Okay. And then part C, same idea. Extend the product. Do some regrouping using the properties that we've talked about over and over and over again. And then we have 2 to the 9th times 3 to the 6th times 5 to the 12th. Any questions about the problems in number 3? All right, the last idea for today is something that we sometimes call power of a quotient property. You have a blank spot that you're supposed to fill in there. So the power of a quotient property states that if we have some fraction, or in this case x over y, all to the a power, where a is just some number, some positive number, that will simplify to x to the a power over y to the 8th power. And if you think about it, it should kind of make sense. It's kind of common sense. So we're going to do one together here. If we have 3x over 5, all of that to the 2nd power, and we're asked to rewrite it as an equivalent expression in simplest exponential form, which means we need to make it as simple as possible. So using the power of a quotient property, that means we're going to have 3x to the 2nd power and also 5 to the 2nd power. Now we just utilize what we just talked about. Simplify the numerator, simplify the denominator, make sure we have everything reduced, and then we're good to go. So that ends up giving us 3x times 3x over 5 times 5 by extending the product. And then do a little bit of simplifying, and we end up with 9x squared over 25. So power of a quotient property. Now there are, of course, other ways of dealing with something like x over y to the 8th power, or to the a power. But where that's really going to come in handy is when we get to negative exponents after the break. Okay? All right, I would like all of you to please do number 4, part A. So my only concern with all this exponent stuff is people trying to cut too many corners and not really thinking everything out. A common mistake in this one is to say that it is 7, a to the 6th, b to the 12th over 27. If you think that, you forgot about the fact that you have 3 7s you're supposed to multiply together. And then what happens is some people who start to see the shortcuts think that, oh, okay, well 7 times 3 is 21. That's not what's happening there. You have to think about it in terms of what's really happening. So if we use the power of a quotient property, and then extend the product, and I went ahead and regrouped while I was doing it. We had 3 7s we're supposed to multiply together, the same as the 3 3s, and so that really should lead us to 343 a to the 6th, b to the 12th, all over 27. Any questions about part A? All right, finish it off. Do part B, part C. We'll compare with our shoulder partner, and then we are finished for today. Part B. Negative 2x cubed y squared all over 3z to the 6th, all of that to the 5th. Utilizing the power of a quotient property, that's what it really means. And then extending the product in the numerator and denominator gives me that big old mess. Hopefully we're able to sort of get around doing it like that. But if you get stuck, that's where you can head. But this is really the sort of thinking that you should be doing. So negative 2 to the 5th is negative 32. X cubed to the 5th is x to the 15th. Y squared to the 5th is y to the 10th. 3 to the 5th is 243. And z to the 6th to the 5th is z to the 30th power. So negative 32x to the 15th, y to the 10th, over 243 z to the 30th. Then, part C, 5 over 2a n squared, all of that to the 4th, utilizing the power of a quotient property, extending the product, and then simplifying, we get 625 over 16a to the 4th n to the 8th. Any questions? All right, we are finished for today.